Okay, so 7b is about applying linear recurrence relations, where you are adding or subtracting the same number each time. So there are three applications you need to know. The first one is simple interest. And I'll take it for granted now that you're here, that you know what simple interest is. You're going to model simple interest with this recurrence relation. Vn plus 1 equals Vn plus d, where d equals r over 100 times V naught. R is the interest rate as a percentage, and V naught is the starting amount. Okay? The questions in exercise 7b are about giving you different pieces of information and working things out. Okay? So if you need help with rearranging equations, I can do that. The next one is what's called flat rate depreciation. Does the school teach accounting at all in year 9 and 10? Like, do you have like a humanities subject where you do accounting and economics? Did you learn about assets, liabilities? Okay. That's fine. So, so I'll need to define a few key terms later on in the course. We're meeting one right now. This term is called depreciation. So if you've done some accounting, you'll know what this is. If you were in my class last year, you might remember what it means. Anyone want to?
When it goes down.
Good. So depreciation means the reduction in the value of an asset. But what's an asset? An asset is just something used to make money. Okay. But in money accounting terms, they'll say asset, and your textbook will probably use the word asset as well. So you don't need to know accounting. Flat rate depreciation is just like simple interest. It's just that instead of going up, you're going down. And you're going down by the same amount each year. So flat rate means go down by same amount each year. So in simple interest, you might add $50 every year. Flat rate depreciation might mean the value of your, I don't know, your car goes down by $500 every year. It's probably more than that. It's a car. The last one is what's called unit cost depreciation. I don't think people ever tell you this in maths. Units means one. Yeah, but as soon as you go outside place value contexts, people don't think of this as one. So unit circle in year 11 maths methods is a circle of radius 1. Unit cost means one use. Okay. So again, it's going to be V1 equals Vn minus D. D is the cost of one use. So I'm presenting this up front to you because when you do exercise 7b, you're going to use one of these three things. It's either going to be simple interest, flat rate depreciation, or unit cost depreciation. So I think what I'll do is I'll do an example of flat rate depreciation and an example of unit cost depreciation. It'll go on Teams. Yeah. It's in your textbook. Gone. Okay, so this is question 7. So we have a printer. No, not a printer, a cherry picker. So this is some sort of.
Damn it! I said cotton picker. You guys are the people that put it away.
Sorry, what was that? I might need to what? No, I wasn't paying attention. I'm busy here. I don't care. This is an unnecessary distraction from my class.
Unnecessary. Racism relevant.
No, I'm kidding. I'm just doing that to spite you. Did it work? Okay. So in this question, we are asked to do the following. Calculate capital D and give a recurrence relation. Just a word of warning, your textbook gives you more support for these questions than you might get in your exam. So you might just be asked for the recurrence relation with no additional help. Okay? So the reason why it's scaffolded in your textbook is to help you as you're learning it. But just remember that at the end of the year, you might not have as much support when doing these questions. So let's get rolling. We're going to use a recurrence relation to model flat rate depreciation. So you found D? All right, what do you think D is? You can. Yep, thank you. All right, does that look right? So 8,200 plus 4,100? Yes, I agree with that. Okay, how do we know? I'll just wait for this side of the room here. How do we know to go down this pathway? Because I think some of you will just be like, okay, I'll do that next time, but how did you know? Like, how will you know when you're on your own without the support of a teacher to do this by yourself? You won't. Okay, so let's do something about that. Yeah. So I think I need to go back a step because I didn't explain this. What does D represent? How much is going down by? So notice this time, I'm not adding D the way I was with simple interest. This time I'm subtracting D, it's going down. It's going down because I'm depreciating, and by depreciating I mean I'm lowering the value of something used to make money. So whether it's a house or a machine, the longer you have it, the less it's worth. These chairs won't be worth much in 20 years' time. No one will want to buy them because they'll probably be broken. All right, so we've got D. Now we need a recurrence relation. Jason, what do you think? Just answer the question. Give me a recurrence relation to model this situation. Vn tech D. Okay, so let's put the number in. Okay? And Taylor? What is Speak up. V naught. So one of the things I noticed last year was people sometimes put Vn here. People sometimes put V naught here or V1 here. It's subtle, but I'm just going to tell you what to do, okay? V naught is your starting value. Vn plus 1 first, define it in terms of Vn. If you do that, you'll be fine. You won't be asked to do anything else in this course. Okay? Remember, you need both the starting point in the sequence and the pattern. You need two equations to define a recurrence relation. Please do not just give me the second equation. Okay?
Let's do 7C now. Let's get it done.
Oh, thank you for reminding me. I almost forgot.
Yeah, we haven't got much time.
Okay, so 7C is easy, okay? 7C, there's only one thing you need to know. So here it is, okay? If V naught is some number, I'm just going to call it A. It doesn't matter what it is. And Vn plus 1 equals Vn plus D, where D is some constant number that doesn't change. Then
Could you go to my office sandwich, please?
So, where was I? So, if we have a recurrence relation where we're adding the same number each time, lowercase d, I don't need to press enter on the calculator 10 million times. We can get a formula for whatever value of n we like. This is the formula. V naught plus n times d. If you look at that for long enough, this shouldn't surprise you, because n times d is the same as adding d n times. So maybe I'll just do an example, because I taught it this way last year and it didn't go so well. So let's do an example. V naught equals 5, Vn plus 1 equals Vn plus 2. Find V100. So I've got a recurrence relation. I'll label them. First, we've got a recurrence relation. And down here, we've just got what's called a rule. The study design calls it an explicit rule. So, see this recurrence relation? I start at 5 and I add 2 each time. You might even remember we did this last year. Find V100 in that room over there. So, I don't want to plus 2 100 times on the calculator, right? I'm going to lose count. Okay? So, wouldn't it be good if there was a way for me to use a formula to give me the 100th term?
There is a formula.
Yeah, it's this thing. Okay? So Vn equals V naught, which is 5, plus n times d. So here, what's d? 2 is the value we're adding each time. Okay? 2 times n. Substitute n equals 100, and you get V100 equals 5 plus 2 times 100, that's 200, and you get 205. So again, if you think about this carefully, if you add 2 100 times, that's just the same as adding 200. Add 2 times 100. This means add d. This means add d n times, or multiply n by d. Okay? That's the only thing that's new in 7c. And then you combine that with the applications in 7b. Okay? So what I think I'll do is tomorrow, I'll go over this again. And tomorrow we will do the same thing, except instead of adding, we'll multiply at the end here. And that will be a geometric sequence leading into compound interest. Okay. Now, if you're feeling overwhelmed and you're feeling a bit lost, because I have presented 3 exercises today, um, it's all in your textbook. So you can read it, and you can always ask me for help as well. But before I let you go, do you have any questions you want to ask, mainly about this page? I know I haven't done a unit cost example, but I don't want to do too much.
Yeah, I'd like a unit cost example.
Do we have time for it?
If you feel like it.
Do you guys want to?
What's the time?
We got about 10 minutes. All right, let's do unit cost. All right, you are doing very well. I think this is quite a demanding class because of the amount of material we're covering. Okay, so we've got a bust worth $32,600, and for every trip, the bust loses $10 of value. So this is like a use. Okay, after n uses, it's going to go down by some amount. So we're going to say let m subscript n be the value of the bus after n trips, or uses as it might be called elsewhere. So here we're asked, find D and state of occurrence relation. And I'll add an extra part, just because I can. Find the value after 10, let's pick a different number. Let's say 20 uses, 20 trips. Alright, so let me recap again. You've got a bus, the bus has some value at the beginning, 32 grand. Every time we make a trip, I'm going to say the bus is worth $10 less. The older it gets, the less it's worth. So I want to set up a recurrence relation, and I want to find how much the bus is worth after a certain number of uses. So, what is D here? You may need to go back to the notes we took from a previous
20.
slide. It is 20. What does D represent?
The amount.
The cost of one use. Okay, that's why it's called unit cost depreciation, because I'm modeling how much value is lost for one use. Okay?
Isn't the cost of one use $10?
Oh, yes, it is. Thank you. So here, D equals 10. All right. What do I need for a recurrence relation? Do we have it?
Yep, 32,600.
Excellent. All right, V naught equals 32,600. Vn plus 1 equals Vn minus D, which in this case is 10. Okay, that's your answers to part A and B there. So you've actually finished the question already. Now for my extra question. You might find it useful to apply what we just learned about 7C here. So I want to find the value of the bus after 20 uses, 20 trips. And that's it. Okay. So you could minus 10 and press enter 20 times on your calculator. But you could also recognize Vn equals V naught minus 10 times n. This is going from a recurrence relation to a rule. Okay? I can substitute whatever value of n that I like into this formula without needing to calculate all the numbers before it. So I could pick n equals 1,000 here, and I get it for free very quickly. So if I substitute n equals 20, V20 equals 32,600 minus 200, which is 10 times 20, which is 32,400. How are we feeling? Is this a bit much for one lesson?
That's pretty good.
You've got the whole holidays to do this. And we don't have class on Tuesday in the first week. So the first time we do is actually going to be Friday in the first week. So we're not going to meet again for about 3 weeks. So you've got hands out there. So you have 3 weeks to get A to E done. So that's why I'm assigning you some of this homework. Yeah.